Welcome back, everybody. Welcome back to the VDC space. Today we're going to be modeling an elastomeric bearing for bridges. So we're just going to keep it as basic as we can, but some elements will have a much higher detail, like bolts. So basically we're going to have three elements. We're going to have the bolts, the plates, and also the elastomer, which is rubber that is reinforced with metal steel. So that's the basis of an elastomeric bearing for bridges. So before I get started, I would like to ask you guys to please subscribe to the channel if you're new. If you already subscribed, hit the notification button as I upload BIM modeling tutorials and Revit tutorials 3 times every week. I cover different topics from wastewater, roads and networks, bridges, buildings, rebar, uh, renewable energy, and so on. So please subscribe to the channel, guys. At least let's get to 2000 this time. So without further ado, let's start with our bearing. So just open up the construction template on Revit 2024 or whichever version you are using. So I'm on level 0 and I'm just going to set up two grids. So it's going to be the vertical grid and the grid running across like this. So since we open up our project, we're gonna use family templates and then we're gonna generate our families and then assemble the bearings inside our project. We're not gonna model it as a single family because I want the quantities and also the elements to be as separated as much. I want to separate the elements as much as I can. It makes it easier for manufacturing guys to quantify and also to demonstrate how everything is assembled. So the first thing is I'm gonna go to file and then say new and then family. And then we're gonna start with our steel plate. So I'm just gonna use metric specialty equipment and say open. And then here we are on the reference level or the floor plan. So I'm just gonna set up my reference planes, which I will use as a guide to generate my parameters. So our parameters are going to be basic. It's going to be the width and the length. So it's going to be a sort of a rectangular plate. So on the side it's going to be 250 millimeters. And then on the left hand side also 250 meters. And then at the top offset is going to be 200 millimeters. Along with the bottom offset is going to be 200 millimeters. So this is what we have. And then I'm going to go to the front elevation and say create and then go to reference plane and then place a reference plane on top. So the thickness of our plate is going to be 100 millimeters. Perfect. And now I'm going to go back to the reference level and then click dimension and then I'm going to set up my dimensions which I'm going to use for my references. My parameters, sorry. So I'm just going to select this and then go to create parameter. And then this one, I'm going to name it width and say okay. And then I'm going to lock it. And then I'm going to select this one and say create parameter. And then I'm going to name it length. And say okay. And then lock it. Then I'm going to go to create extrusion and then place a rectangle using these reference planes. And then I'm going to apply the material to this. So I'm just going to type in metal. And then I'm just gonna scroll down and then I'm just gonna look for metal. So I'm gonna select this one and load in metal and say apply and then okay. And then I'm gonna say finish edit mode. Then I'm gonna go to the front elevation and then I'm gonna drop this and make it 100 millimeter thickness. And then I'm gonna lock it and then I'm gonna type in AL on my keyboard for align, and then I'm gonna align this extrusion to this reference plane and lock it in order for me to control its height. So the last parameter I forgot to generate was the height. So I'm gonna select my dimension and then apply the height between these two reference planes. Select this thickness actually and say create parameter, and then I'm gonna name this one thickness and say okay. And then I'm gonna lock it. And then I'm gonna load it into our project. I'm not gonna save this, I already did. And then I'm just gonna place it where the grids intersect. Perfect. And now, let me just open up the south elevation. So basically, we're gonna have two plates, and then the single elastomer rubber, and then we're gonna have four bolts. So the next thing we're gonna generate is the element which I'm actually excited to model, which is the bulk. So I'm gonna go to new family. So we're gonna generate our bulk. Um, we're gonna use the matrix specialty equipment for this one also and say open. So here we are on the floor plan. So for our bolt, we're gonna have obviously the head or the nut, and then we're gonna have the shank along with the thread. So we're gonna start with we're gonna go with let me just go to your front elevation for this one, and then reference plane, and then I'm gonna set up my reference plane on the bottom of the reference level, and then I'm gonna select this and then set up my offset. So my offset, I'm gonna make it. I'm gonna actually make it 200 millimeters. Perfect. And then I'm gonna go back to the reference level. So and then I'm gonna go to create. And then for the first thing we're gonna model is our nut or our head. So I'm gonna select extrusion, and then I'm gonna go with this option, the polygon. I'm gonna place it right in the middle, and then take it further. So and then I think I'm gonna make it. Let me just make it so it's gonna be 20 from this middle reference plane to this section. So overall it's gonna be 40 millimeters. Perfect. And then I'm just gonna apply the material to this. So I'm gonna make this one also. So I'm just gonna type in steel, and then I can actually use metal again. Actually, no. Let me just go down. So I'm just gonna say stainless steel and say apply. Okay. And then I'm gonna say finish edit mode. And I'm gonna go back to the front elevation and then set up my offset. So from the top, I'm gonna hover over the top and then press tab on my keyboard until only this line is highlighted. And then I'm gonna set up my thickness. So I'm gonna make it 20 millimeters. Perfect. Now if I open up the 3D view, this is how our nut looks. But I want to create like a chamfer on the edges of this nut just to make it more realistic and better for visualization. So I'm just gonna go, and in order for me to do that, I'm gonna go to the front elevation and then create, and then I'm gonna go with void forms. So I'm gonna drop down the void forms, and then we're gonna use this option, the void revolve. So I'm gonna select it, and then from there, um, let me just go to create. It's a reference plane, and then I'm just gonna randomly place a reference point this side. I'm gonna select it, and then from the edge of this polygon, I'm gonna offset it by. Let me just make it 5 millimeters and see. Actually, okay, let me make it 2.5 and press enter. And then I'm gonna select my line, place a rectangle like this. So I'm gonna make it 50 millimeters and then bring it down by 20 millimeters, and then I'm gonna take it diagonally to the first insertion point that we started from. And then after I generated my profile, I'm gonna select axis line. So for my axis line, I'm gonna place it right in the middle of our head or our nut. So I'm gonna make it 20 millimeters. So it's gonna be the total thickness of this knot. So that's where our axis line is gonna be placed. So this profile is gonna revolve around this nut by using this axis line as a reference. So I'm gonna say finish edit mode, go to the 3D view, and this is how it looks. Now it's more representative. Or if you guys are not satisfied, you can select our word form again, and then edit revolve, and then I'm gonna go to the front elevation, And then I'm gonna remove this profile, and then I'm just gonna increase this distance and make it 5 millimeters. I'm gonna select my line again for profile, and then I'm gonna take it to the left by 50, bring it down by 20, and then diagonally I'm gonna take it back to the origin of the first insertion point where we placed our profile. We say finish edit mode, open up the 3D view, and this is how it looks. Perfect. So the next thing is we're gonna model our thread along with our shine. So this also is an exciting part. So I'm gonna go back to the reference level, go to create and say, and then I'm gonna say extrusion. So and then I'm gonna select my circle option, and then from this insertion point, I'm gonna draw my circle. So I'm gonna make it 10 millimeters in radius, so the diameter of this thread or shank is gonna be 20 millimeters. And then obviously stainless steel, and I'm gonna say finish edit mode. Go to the 3D view, actually go to the front elevation. I'm gonna bring it down to that bottom reference level, lock it, and then bring this down under the thread or the head or the nut. So and then if I go to the 3D view, this is what it looks like. But I think we can increase this by, so we're gonna make the radius 20. No, actually that doesn't work. We can make it 10. We just go, okay, 15. Yeah, I think this works. Well, actually we can make it, let's just go back to reference level, edit extrusion. We're gonna make the radius 12, so the diameter is gonna be 24. And then I'm gonna go to the 3D view. This is how it looks like. So if I go back to the front elevation, uh, the next thing is we're gonna do the thread. So for the thread, we're gonna apply the same logic we did with creating the chamfers on top of our nut or our head. So we're gonna go to create and say void forms. We're gonna choose the void revolve again, and then we're gonna say we're gonna draw our axis line first as a reference. So we're gonna select the axis line, and then from this point we're gonna take it upwards by I think we can make it 100. No, we're gonna make it 18 millimeters. I think 18 millimeters is fine. And then we're gonna say line. We're gonna select our line, and then from this point we're gonna take it to the right by actually we're gonna make it we're gonna make it 4 millimeters to the right, and then we're gonna draw a diagonal line upwards at 4 millimeters also. And then I'm gonna select this line, and then I'm gonna say copy, and then from there, actually let me just do this. I'm gonna draw another line that goes down like this, and then pull this one to the right like this, and then remove this line, select this, select these three lines, and then I'm gonna say copy, and then I'm gonna copy from there to there, and then we're gonna copy until we meet the top of our axis line. So that's the top of our axis line. So we can just end our thread there, our profiles for our thread. So I'm just going to, so I'm just going to connect this line to this point, and then from there I'm going to draw another line, or is a vertical line that goes upwards until it meets the profile. So it's going to be a vertical line until it meets that point. Perfect. So this is your profile, and this is your axis line. So these profiles are gonna revolve around this axis. So I'm gonna save, finish edit mode, and then the extrusion is gonna cut this solid. And then when you go to the 3D view, this is how it looks. So this is your thread. That it is to shade it, and then as you can see, this is basically your 3D bolt. So I'm just gonna load it in and say loading to project and close, and then I'm not gonna save this, I already did. And then I'm just gonna place it randomly there and set up my reference plane. So I'm gonna set up my reference plane there and there, and then I'm gonna place other ones that are running across like this, and then I'm gonna offset them from the edge of our steel plate. So I'm gonna offset them by 40 on all sides. So it's gonna be 40. And then on this side also it's gonna be 40, 40 volts. And on this side is gonna be 40. Also this side is gonna be 40 mils. Perfect. And then I'm gonna select my bolt and then I'm gonna place it where the reference points are intersecting. So if I go to the 3D view, this is what we have. If I go to the south elevation and then set this to fine and then this to wireframe, I'm just gonna select my bolt and then move it on the attach it on top of our plate like this. So I'm gonna select it and then copy it to the other reference point. Control select the two of them, go to the floor plan and then copy it to the other reference points. So if I go to the 3D view, this is how it looks. So I can just change the height of this steel plate. So it's 100. So I'm just gonna change it to 50 and say okay. So this is how it looks at 50, and then I'm gonna say I'm gonna select my bolts, go to the south elevation, and then move them down like this. So the next thing is basically we're gonna have another plate on top. So the plates and the bolts are redundant. So the next and last element we're gonna actually generate is the elastomeric side. So we're gonna go to File and say New Family, and then we're gonna go to Metric Specialty Equipment and say Open. And then for the elastomer, I'm not gonna apply parameters. I'm just gonna do the geometry. So basically, we're gonna say extrusion. And then I'm gonna place my rectangle like this and then select the one side and then I'm gonna offset it by so the total width of the elastomer is gonna be 300 millimeters and then the length is gonna be 200. So this side is gonna be 150 and then the other side so it's gonna be 300 in total and then this side is gonna be 100 millimeters and then in total it's gonna be 200 millimeters. Perfect. And then I'm gonna say finish. Go to the front elevation. Then I'm gonna hover over here, press tab on my keyboard, select this line, and then set the thickness to. So it's gonna consist of four elements, which are multiple. So we're gonna have the outer layer, we're gonna have the steel plates, the inner layers, and the side covers. So the outer layers are the ones that are going to be based on top and the bottom. So they're going to be made of rubber and the thickness is going to be 10 millimeters. The steel plates, there are going to be four of them and then they're going to be embedded within the rubber, within the elastomer, and then they are going to be 5 millimeters in thickness. The inner layers, which are the rubbers, there are going to be three of them and they're going to be 10 millimeters in thickness. And then the side covers, they're going to be two of them which are running around the, which are running across the within the parameters of the elastomer. So they're also going to be 10 millimeters in thickness. So I'm just going to select this extrusion and then copy to the top. And then uncheck my constraint, copy it. So It's gonna be 4, 7, 4, 7, 3, 4, 5, 6, 7, 8. So these two, they are gonna be the outer layers. So I'm gonna apply materials to them, and then I'm gonna assign the rubber to them. So it's gonna be rubber, load it in, and say okay. And then this one, I'm gonna skip one, and then press this one, skip one, press this one, skip one, and then press this one. So these ones, so it's gonna be 1, 2, 3, 4. So there are 4 of them. So this one are gonna be made of steel. So I'm just gonna type in steel there. And then when I drop down, so I'm just gonna load in metal and say apply OK. And then I'm gonna skip the outer layer, the steel, and then press this one, skip one, press this one, skip one, and then press this one. And then these are also gonna be rubber. So these ones are gonna be made of rubber. And then I'm gonna say OK, open up the 3D view, and then choose the level of detail to fine, and then the graphics to realistic. As you can see the distinction between the two materials. So this is the steel, and then these are the rubbers. So you're gonna have to apply also the side cover, which are made of the rubbers. So I'm gonna go to the front elevation. Actually, no, the reference level. I'm gonna go to create, and then we're gonna create a sweep, solid sweep. We're gonna select sketch path, and then select our rectangle, and then place it around the perimeter like this. And then I'm gonna delete this line because I want this reference level, this green line, which indicates where you can place your profile to be based this side, so that I can view it from the front elevation. And then I'm just gonna close it like this. And then go to finish edit mode, edit profile, set my reference to the front elevation. So I'm just gonna draw my profile. So I'm gonna take it upwards like this, and then take it to the left by 10 millimeters, which is the thickness of our rubber. Take it down like this. So this is our profile, and then I'm gonna apply rubber to it. And say finish edit mode. Go to the 3D view. Just to show you how this sweep works. So this is the profile. This is the path around the parameter, and then we can say finish edit mode. So this is how it is applied. Perfect. Now I'm gonna load it into our project. I'm not gonna save this, I already did. And then I'm just gonna place it right in the middle like this. Go to the 3D view, and obviously it's crashing. I'm gonna select it, go to the side elevation, and then I'm gonna place it right on top of our plate. And then I'm gonna select my plate, select my bolts, right click, select all instances, visible in view, mirror draw axis, and then I'm gonna find the big point of our elastomer and then draw my axis there, and then it's gonna and then my plate is gonna be my plate along with our bolts are gonna be mirrored. But as you can see, our bolts are not mirrored, and then I'll show you the reason why that is. So I'm just gonna say undo, select my plate, copy, and then we're gonna copy it on top of our elastomer. So for our bolts, I'm gonna select it and go back to edit family. And then the reason why it wasn't mirrored is because I set it as always vertical. So it's not versatile in terms of movement. So how your families are placed on the project uh, depends on these parameters. Wet plane based, enable cutting in, always vertical cut with bolts, and so on and so forth. So I'm just gonna uncheck this always vertical, load it into our project. So I'm not gonna save this and say overwrite existing views. So I'm gonna select my bolt again, and then draw my axis for in order for me to mirror this bolt. And then actually it still doesn't work. So let me just so I can just rotate it at this point. Still doesn't work. So I'm just gonna go back to edit family, And let's see how this is. Just so if I say work plane based, and then upload it into our project again, override, and then we just select this one, mirror. There you go. So the solution is when you go to edit family, you're gonna set it to work plane based. So if I just hover over here, Revit actually demonstrates graphically on how work plane based families work when we place them on a project. So this is how it works. So I'm just gonna load it in, and this is what we have. So I'm just gonna remove this one, uh, select these bolts, and then I'm just gonna mirror them like this. Open up the 3D view. Hopefully there are no duplicates, so I'm gonna select this one, go back to the south elevation, and then mirror it like this. Go back to the 3D view, and this is what we have. So this is basically our elastomeric bridge bearing. Now, the last thing I'm gonna do is I'm gonna load this into Autodesk Navisworks, and then I'm gonna show you guys basic animation of how this thing can be assembled. But it's just gonna be basic. It's not gonna be much detail in terms of. We're just gonna uh, keep it as basic as we can, just to show you guys basic animation in Navisworks. So the first thing is I'm just gonna export this to IFC Industry Foundation class. So I'm just gonna say save, and then I'm just gonna browse and go to the documents and say save, and then modify setup. Everything is fine. I think we can use 2 by 3. Additional content, make sure it fits the elements. I think it's fine. Expect only elements visible in green. I think that's fine. And then property sets, we're not gonna modify any of these, so I'm just gonna say okay and say export. So everything is exported, and then I'm gonna open up Navisworks. So the reason why I took it to IFC, I know you can export it to Navisworks if you have the add-in, but I don't have the add-in. So I took it to IFC, and then I can load an IFC model into Navisworks. So if I open Navisworks, I'm gonna say append, and then I'm gonna go to document, and then this is my model. So it's IFC. Actually, you can filter out the formats of the the models you want to load in. So you have Rhino, you have 3ds Max, you have SolidWorks, and so on and so forth. So I'm gonna load in my IFC model, select it, and save it. So it's gonna take a while, surprisingly, because this is not a heavy model. I don't know why it's taking. Let me just cancel the parent project. Just close this down. Just save this block document. Save. Go to Navisworks. So here is just open it. So here's our bearing. So the first thing is this is the Navisworks interface. So the first thing we're gonna do is we're gonna go to animation, and then we're gonna open up under create. We're gonna open up this animator option. So this is what we have on the animator. So the basis of animation in Navisworks is you have to add like scenes, and then you have to modify those scenes to make it uh, in order for you to create an animation for visualization and so on. So previously on my previous company, uh, I modeled the solar panel tracker. So I had to like read the manual, the PDF of the manual, and then I have to create like an animation demonstrating how everything is assembled to make it easier for guys at site to see how the solar tracker is assembled, because people learn in different ways. There are people who learn by visualization, there are people who learn by using complex formulas and so on and so forth. So you have different ways of doing things. But anyway, so this is what we have. So the first thing is, I'm just going to keep it as simple as you can. This is our elastomer. Remember, these are our two plates and these are our bolts. So I'm just gonna I'm gonna add a scene to this and say add scene. So this is our scene, this is our timeline, and then these are our keyframes. So we have scene one. So for scene one, I'm gonna start with our plate. I'm gonna select my plate, and then on scene one, I'm gonna right click and say add animation set. And then I'm gonna say from current selection, and then I added my first animation set. And while it's still selected, I'm gonna select this translate animation set, which gives you an option of moving your element up or down or sideways. So I'm just, otherwise you can also modify the position of your element by typing in parameters on the XYZ. So I'm gonna select my plate, and then I'm gonna set my, actually, yeah, I think it's fine at 0 for the moment. And then I'm going to select my animation set. And then in order for you to add a keyframe, you're going to go with this option, capture keyframe. And then while it's still at 0, 0, I'm going to add my keyframe. And then I'm going to type in 1. So it's going to take it to 1. And then I'm going to set my Z level to minus 0.5. And then I'm going to add another keyframe. Perfect. So if I select this keyframe, so the Z value is not set, so I'm just gonna say set it to minus 0.5 and then add the keyframe, or I can just move it manually, and then you can also set it and then make sure you add your keyframe. Now let me just demonstrate to you how this happens after you set up everything. So if you select scene one and then uh, select stop just to bring it to the beginning, and then you press play. This is how it moves. So the next thing is I'm gonna select my belt, my third belt, and then I'm gonna select scene, right click on scene, add animation set from current selection, and then while it's still at 1, I'm gonna set it. Actually, I'm gonna set it to. Yeah, so while it's still at 1, I'm going to add a keyframe for our box. So I'm going to say capture keyframe, and then I'm going to set it to 2, and then I'm going to set my Z values to minus 0.5, and then I'm going to add another keyframe. So if I select this keyframe, and as you can see, it's still at 0, I'm just going to manually move my bolts, and then I'm going to adjust the Z value and set it to minus 0.5, and then add the keyframe again. So this is how it works. If I select my scene one, press stop just to bring it to the beginning, I'm gonna press play, and then this is how it looks. So the next thing we're gonna do is the elastomer. So I'm gonna select my elastomer and then right click on scene one, add animation set from current selection. While it's still selected, I'm gonna add another keyframe and then set this one to 3, and then I'm gonna add another keyframe at 3, but this time I'm gonna set my Z value to 0.5 again, and then add my keyframe. So if I select this keyframe, as you can see, it's still at 0 for some reason. So I'm gonna move it manually, and then I'm gonna set it to minus 0.5, and then add the keyframe again. So if I select scene 1, and then bring it to the beginning, I'm gonna press play, and then this is how it looks. So I'm gonna apply the same logic to this one. So I'm gonna select my top plate, scene one, right click, add animation set from current selection. And then I'm gonna add a keyframe. I'm gonna add a keyframe. I'm gonna set this to 4. Add another keyframe. I'm just gonna move this manually and then set the Z value to minus 0.5 and then add the keyframe at the end. And then I'm gonna select my top bolt, right click on scene 1, select my top bolt again, right click on scene 1, add animation set from current selection, and then while it's still selected, I'm gonna add a keyframe. I'm gonna change this to 5, add another keyframe, and then I'm gonna move this manually, and then I'm gonna set this Z value to minus 0.5, add the keyframe again, and this is what I have. But obviously it doesn't make sense because these boards are moving like the opposite direction. But I'm just trying to show you guys like the basis of animation in Navisworks. Just to make this tutorial short, I just wanted to show you the basics of this. So obviously you can move these bolts from the sides and then to the top in order for them to go into the plate, and then you can move the plates along the bolt down so that they can present to the elasto. But if I go back to scene 1 and then set it to the beginner and press play, this is how it looks. Perfect. This is what we have. So this is the end of the tutorial, guys. I hope you learned something. The most interesting thing about this tutorial, in my opinion, was generating the 3D board. That's where I actually saw the versatility of using the revolve form or the revolve void in family templates. So I'm gonna use it very much often when it comes to generating some of the families, especially mechanical families. So thank you guys for watching, and I hope I can see you on the next tutorials. I think this week, based on my schedule, I'm gonna do a concrete facade, and then I'm gonna do the solar trap. So tune in. Please like and subscribe if you like. It helps with the algorithm. So many people may find my channel. So many people may learn more. And I hope you guys can tune in on the next tutorial and see you. Peace.